Hey guys, this is Rishendra. Today we'll continue with Llama Index. So, first topic for today is node parsers. So, node parsers determine how documents are split. So, for example, you can split a document by sentence, or maybe you can split a document by paragraph or semantic splitters, token splitters. So each type of splitter affects the retrieval performance. Next is transformations. So transformations modify documents before indexing. So for example, like cleaning text, removing duplicates, normalizing, formatting, extracting tables, or maybe like generating metadata. Next is post processors. So after retrieval, the results may still require refinement. So post processors can remove any duplicates, filter irrelevant chunks, reorder results, trim long responses, and improve relevance. Next is re-ranking. So similarity search is not always perfect. So re-rankers reorder retrieved nodes using more advanced models. So that the pipeline for this would be like there's a retriever and the retriever has like a top 20 nodes, and then the re-ranker reorders the retrieved nodes, and then there are like top five best nodes, and those top five best nodes will go through the large language model. So this greatly improves the answer quality. Next is hybrid search. So hybrid search combines keyword search and semantic search. So, for example, if you are like searching for like invoice 2023, so the keywords locate invoice and the embeddings understand the context. So it's like the best of both approaches. Next is metadata filtering. So metadata filtering is like instead of just if you give like a file and you just like filter like the department, HR, and the year 2024. So the retriever ignores like everything else. Next is multi-model support. So Llama Index supports more than text. So it can work with images, audio, videos, tables, charts, and mixed documents. Next is structured data. So not all information is text. So Llama Index can also support like CSV, JSON, Excel, SQL, and data frames. Next is SQL integration. So Llama Index um, can connect directly to relational databases. So, for example, if the user asks a question like which employee has the highest salary, so the framework translates the request into an SQL query, retrieves the data, and provides a natural language response. Next is knowledge graph index. So, a knowledge graph index represents entities and their relationships. So, for example, like Tesla, for example, like a single sentence, like written in five different lines. So, like Tesla CEO, Elon Musk, located in Texas. So, this helps answer relationship based questions. Next is graph RAG. So graph RAG combines graph structures with retrieval augmented generation. So instead of retrieving isolated chunks, the system retrieves connected entities. So graph RAG excels at reasoning across relationships. Next is evaluation. So evaluation measures system quality. So common metrics include like retrieval accuracy, faithfulness, answer relevance, context precision, latency, and token usage. Next is observability. So observability helps developers understand like what was retrieved, which chunks were used, how many tokens were consumed, how long each step took. So this simplifies like debugging and optimization. Next is Llama Parse. So Llama Parse is a specialized document parsing device, specialized document parsing service developed by the Llama Index team. So it is particularly effective for extracting structured content from complex PDFs that contains like tables, multi-column layouts, charts, images, forms, and financial reports. So compared to like basic PDF text extraction, so Llama parse preserves document structure much more accurately, making retrieval more reliable. Next is like the complete workflow of Llama Index. So Llama Index, first you load the documents and then parse the documents, and then split the documents into nodes. Then you can generate the embeddings and store the embeddings in a vector database, and then create the index, and then you and then the um, AI receives the user question, and the retriever finds the relevant nodes, and then the response synthesizer combines context, and then the LLM generates the final answer, and then it returns the response to the user. Next, the advantages. So the advantages of Llama Index include like it is simple in a modular structure. It integrates with many large language model providers and data sources. It is optimized for retrieval augmented generation. It supports vector search, keyword search, graph retrieval, and hybrid retrieval, and it is flexible indexing and retrieval strategies, and it is easy integration with vector databases and SQL databases. It has built-in support for chat engines, agents, and evaluation tools, and it scales from small personal projects to enterprise level applications. Next is the limitations. So, the limitations include like the performance heavily depends heavily on chunking strategy and embedding quality. And the large indexes require additional storage and maintenance. And then the retrieval quality may decrease if the metadata or parsing is poor. And some advanced features introduce additional complexity. And then external LLMs and embedding APIs may incur the costs. So next, so la- here are some differences between Llama Index and LangChain. So, Llama Index, the primary focus for Llama Index is on like data indexing and retrieval, whereas the primary focus of LangChain is building complete LLM workflows. The core strength of Llamadex is connecting LLMs to external knowledge, whereas the core strength of LangChain is orchestrating chains, tools, agents, and workflows. Next, Llama Index has a extensive built-in support for indexing, whereas LangChain has a more limited and often relies on integrations for indexing. Next is retrieval. So Llama Index is highly optimized for RAG, but LangChain supports retrieval but is less specialized. So, in the summary, Llama Index is a framework that enables large language models to work effectively with external knowledge sources. So it is a core work. Its core workflow is to like load data, parse it, split it into nodes, create embeddings, build indexes, retrieve the most relevant information. So optionally re-rank it, synthesize a response with an LLM. So yeah, that is the end of Llama Index. So, then, yeah. So that's it for today, and I'll see you again tomorrow. So, yeah. Thank you all. Bye.